Okay, question 7, part D. We're continuing from the previous parts of B and C. So now we have to show that there's exactly one value of theta for which dA over d theta is equal to 0 for our domain of theta between pi and 0. Okay, so how we're going to start this? We're going to begin by equating dA over d theta equals 0. So from part B, we know that's equal to this. So we'll begin by writing it out. So cos theta sine theta minus theta cos theta over 2 theta cubed. And we want to make that equal to 0. Alright, so now how are we going to solve this? Because we don't really know how to solve this area with Newton, even with Newton's approximation, we can only find an approximate answer for this. So we don't know what to do. So we're going to have to multiply the denominator first. So we've got w squared cos theta outside of sine theta minus theta cos theta. Okay, and that's going to be equal to 0. So that would mean that cos theta has to be equal to 0, or this thing has to be greater than, or it has to be equal to 0. All right, but from part C, we learned that sine theta minus theta cos theta is always greater than 0. So we don't have to care about if this equals to 0 because it simply doesn't in that domain. Okay, so we were just going to equate this to find if that equals 0. So either cos theta had to equal 0, or what's inside the bracket has to equal to 0. But as I said, we can't really figure this out with our mathematical knowledge that we've learnt. But we have part C to help us because we know now that this equation cannot equal 0 because it's greater than 0 for our domain of theta between pi and 0. So this doesn't even matter for us because it just doesn't equal 0. So we don't even have to care about it now. But make sure you state that when you do your working out. So now we just have to pay attention to cos theta is equal to 0 because w squared is a positive constant. So cos theta is equal to 0. Now this should be very simple for you guys. So we know that theta would have to be equal to pi on 2, 3 pi on 2, plus, and not plus, and so forth and so forth. But because theta has to be between these two values, we don't even have to care about this second one. So theta equals pi on 2 is our only value for theta in which d alpha on d theta is equal to 0. And if you want, you can prove that this is in fact a minimum, or a maximum I think it is, by testing that d alpha over d theta and also our value for theta. You can draw up your little table and have pi on 2 here, maybe like pi on 3, and maybe 4 pi on 3. Not even, sorry. Maybe 5 pi on 6. And then what you would realize is that you would get a negative value, you'd get a positive value, and you'd get a negative value, so that you have, in fact, a maximum point. So with that being said, you have found that theta equals pi on 2 is the only point in which dA over d theta equals 0, and that's how you satisfy that question.